Okay, so we've been talking about factoring, and in this case, as it applies to polynomials, we're trying to take a polynomial expression and break it down into its prime factors. And those prime factors are also polynomials. Okay, so to start us out, we're going to look at a flowchart. Okay, a flowchart is just a diagram that kind of helps you through a complicated process. It steers you through. You make choices along the way, and it helps you solve a problem. So you may remember doing some flowcharts and stuff in geometry last year when you're doing some flowchart proofs. Don't worry, we're not proving anything here. So here is a fun example of a flowchart, and it's a troubleshooting flowchart. This is actually the cleanest version of this flowchart that I could find on the internet. There's a couple of variations with spicier words thrown in there. Anyway, so on this flowchart, I start at the top and I work my way down to the bottom. So right at the top, there is a question that you're supposed to answer. Does the darn thing work? So we're assuming something's broken, and it's asking, does the darn thing work? So I either answer yes or I answer no. Okay, so let's say, okay, I'm using this flowchart, so obviously it doesn't work, so I answer no. I follow the arrow, and it says, well, did you mess with it? Now you answer that question. Did you mess with it? And you're probably going, hey, there's somebody at the door, so I'll be right back. So we just said that we messed with it, yes. So we follow the arrow on the yes, and it says, you moron. And then we keep going, does anyone know? So let's just say that nobody knows about it. Okay, so we follow the no. It says hide it, okay? And I keep going, no problem. So you've just solved your problem, okay? And that's what a flowchart will usually help you do. Okay, so specifically for this, I've made for you a flowchart for factoring, because factoring can get to be a pretty complicated business, and so we want something that's going to help us through all of the process. So here's a small picture of it. You're not going to be able to see it from this picture, so if you look right up above my head, there's a copy of it that I suggest that you print out. It'll save you from having to write some of the things down whenever you're taking some notes. And of course, you'll be able to use it on your homework. You can use it on your quiz whenever we take it. Okay? So according to this chart, I want you to, if you haven't already, print that thing out, stop the video, go print it out, come back and look at it. All right, so I'm going to assume you have that chart right in front of you and you're studying it and you're going, wow, this looks pretty amazing. This one starts from top, goes down to the bottom. And according to this chart, what's the very first step that we're going to take whenever we factor a polynomial? So if I look at the very, very top of this chart, right up here, it says the first thing that I'm going to do is I'm going to look to see if my polynomial has a GCF. Okay, so that is our first objective. It's being able to factor a polynomial by taking out a GCF. GCF stands for greatest common factor. It is something that is common to every single term in our polynomial, and it's the biggest one possible. So if you look at this picture, this is pretty clever, that in this picture there are some similarities. There are some factors that every single character in here have in common. Just take a look at the picture and you might be able to notice that there are certain things that every single one of these guys has. One thing is, every single guy in this picture is a male, so there is a common factor. Okay, if I look, it looks to me like every single one of them has a mustache, and maybe every single one has a sash of some kind, and maybe every single one of them has like some ruffly thing around their neck. That's the kind of thing that we're looking for. We're looking at all of the terms and seeing what they all have in common so I could pull it out. Okay? So the first step at factoring is basically using the distributive property backwards to take out the greatest common factor, the GCF. Okay? It is the term, it's a monomial term, that divides evenly into every single term of your original polynomial. So look down at the bottom here. I have 2x squared plus x. If I look at both of those terms, a 2x squared and an x, is there something that both of them have in common? And the answer is yes. They both have a factor of x in common. So I can pull that out And basically what I'm doing is I'm using the distributive property backwards. Or I can think of it like this. If I divide both of these things by x, if I divide 2x squared by x, I get 2x. If I divide x by x, I get 1. And that's the quotient that's left over. Okay? So, x in this case is our greatest common factor, and the 2x plus 1 is the quotient that's left over after I divide everything by that GCF. Taking out the greatest common factor, it's always the first step because it leaves the quotient as being something that's simpler for you to factor. Sometimes after you factor the GCF out, that's all you have to do. You don't have to do anything else. But of course, you always want to check back, is that 2x plus 1, is that quotient there, is it prime? Because if it's prime, you're done. If it's not, you have to keep factoring. Okay? So taking out the GCF is always the first step. Battery problems. So factor out the GCF in each of these problems. So if I look at each one of these terms, I can think of the number part, the numerical part, separately from the variable part. Okay? So let's look at each one of these. I got a 2, I've got an 8, and I've got a 6. So each one of those is even, so I know that I could at least pull out a 2. Okay? Now look at the variable part. If I pull out the variable x squared, okay, that's in the first one, but the second one just has an x, and the last one doesn't have any x's at all, which means that it's not common to every single term, so I can't pull it out. Y's in the first term, y's in the second term, but it's not in the sixth, so we can't pull it out. So 2 is the greatest common factor. It's the only thing that every single one of these terms has in common. Okay, so to get the quotient, just divide everything by 2. So if I divide 2x squared y by 2, I get x squared y. Plus, and the 8 divided by 2 is 4xy. And then I divide the negative 6 by 2, get negative 3. And for this one, that's as far as I'm going to be able to take it. And so that's my answer. Okay. On the next one. Okay, this one looks a little strange. But there is a greatest common factor between these two terms. I don't want to distribute out the x to that first set of parentheses and the 5 to that second set of parentheses, because what's in the parentheses is exactly the same. X plus 2 and x plus 2. It is common to both of these terms, so it is the greatest common factor. So this is equal to x plus 2 in parentheses. Okay, and then I open up a new set of parentheses for my quotient. If I divide the first term by x plus 2, it'd be gone, and I'd just be left with that x. Okay, if I divide the second term by x plus 2, it'd be gone. It's 1, actually, and I'd be left with plus 5. And so now I've just factored that by factoring out a kind of strange-looking greatest common factor. Okay, so here are a couple of problems for you to do, doing the same thing. All you simply have to do is factor out the GCF. So please go ahead and pause the video and get some practice taking out the GCF. All right, let's check our work here. So here are our answers. Now, one thing that I'm going to point out to you, something that I'm going to suggest that you do too, is anytime the leading coefficient is negative, pull it out too. Anytime the leading coefficient is negative, pull it out as part of the greatest common factor. Even though not every single one of those is negative, it's going to make the quotient part easier to factor if the leading coefficient is positive instead of negative. That's why we want to take it out. Okay? So I see that they have in common a 2, but since the leading coefficient is negative, I'm going to pull that out too. You may not have done that. That's okay for this one, but I want you to get in the habit of trying to do that, trying to remember to do that. And remember, what you're supposed to do after that is you're supposed to look at that second part there and see, hey, is that part prime? Is that prime? And right now we may not know. Don't worry about it. Eventually you will know. Okay, looking at number 2. Number 2, all of the numbers are even, so I can pull out a 2. And as far as the variable part goes, what I get to pull out is x squared. Greatest common factor for all the variables is x squared. And what's interesting about it is when I pull it out, even though it's called the greatest common factor, it is the lowest power of the x, because the lowest power is the one that divides evenly into every single other power. So that lowest power is the x squared, so it gets pulled out. Okay, number 3 may have been a little bit more troublesome just because you had some larger numbers, And a suggestion here might be, if you have these large numbers and you're not sure where to start, try making a factor tree and seeing if some of the factors line up and if some of those factors are the same. And it turns out that every single one of these has a factor of 13. So numerically, that's what I get to pull out. And then for the variables, I'm looking for the smallest power of each one, because that's the greatest thing that would go into all of the rest of them. So the smallest power on the C is 2. The smallest power on the N is to the first power, and the smallest power on the K is to the third power. Okay? And then finally, on number 4, what's common to both of these is the quantity, the binomial x squared plus 1. Pull it out, and then what I'd be left behind with, the quotient is 2x minus 5. And then again, we would want to look at this thing, and even this one, and determine if both of those are prime. If they are, you're done. If they're not, you need to keep going. Okay, so that concludes the video on taking out the greatest common factor. And remember, that is always the first thing that you want to do whenever you properly factor a polynomial.